Today we're going to continue to talk about polynomials, but we're going to be dividing them and talking about how to factor them a little bit using both long division, synthetic division, and a new method that we're going to talk about today. So long division should be reviewed technically from Algebra 2. We are going to be dividing these two polynomials, f of x and g of x, and it's just like when we were learning how to do long division way back in grade school. Remember that dividing is just the opposite of the inverse of multiplying. So we're trying to figure out some number up here times this x minus 2, and that's going to equal our polynomial, that f of x. So to do that, I know I'm going to take 3x squared, and if I multiply that by x, that's going to equal 3x to the third. Well, if I take that 3x squared and also multiply it by that negative 2, I get negative 6x squared. And now I'm going to subtract both of those. That equals 0. Negative 2x squared minus 6x squared is equal to a positive 4x squared. And then we bring down our other remaining terms, and we repeat the process. I know that if I multiply 4x times x squared, that's going to get me 4x squared. If I multiply 4x by negative 2, that's going to equal negative 8x. And again, I'm going to subtract that entire thing. This equals 0. 2 minus a negative 8x is a positive 10x. Bring down my minus 5. And one more time, if I were to multiply 10 times x, that would equal 10x, and 10 times negative 2, that would equal negative 20. I'm going to subtract that entire thing. 10x minus 10x is 0, and I am left with 15. That's my remainder. So my remainder, I add that at the end as 15 over x minus 2, that guy that I'm dividing by. With synthetic division, it's a little bit easier. We are going to be doing an upside down division sign, and I look at this g of x, what I want to divide by, and I'm going to divide by the 0. So instead of dividing by x minus 2, I'm just dividing by x equals positive 2. And then I'm going to write just the coefficients of all of the values from f of x. And remember, with synthetic division, if we were missing like an exponent, if it skipped from x to the third to just 2x, I would have to put a 0, a placeholder for every exponent value. So we start by bringing that first number down. I do 2 times 3, that gets me 6. With long division, I subtracted my numbers. With long division, I'm going to add. So negative 2 plus 6, I do get a positive 4. Multiply 4 times 2, I get 8. Add those together. 2 times 10, I get 20. Add those together again, I get 15. The same thing that I got before. Again, this is my remainder. And I have a polynomial. If you notice, the values that I got when I did synthetic division are going to be the same as the coefficients as when I did long division. Every time I start with my last number being my remainder, then I have my constant term, my coefficient of x, my coefficient of x squared, and so on and so forth. So my answer, my polynomial, would be 3x squared plus 4x plus 10, again with that remainder, 15 over x minus 2. So we see we get the same answer whether we do synthetic division or long division. So that was the Algebra 2 version. The pre-calc version, luckily, is actually a lot easier than both of these two ideas. In order to get that remainder, we can just evaluate f of 2. So if I evaluate f of 2, plugging it into that same function up above, and I plug all of these numbers just into my calculator. If you wanted to multiply them in your head, go for it. But when I multiply, cube, add together, subtract away, I would end up getting 15. So my remainder is the same no matter which method I choose to use. So the pre-calculus is what we call this remainder theorem. And it says if we have a polynomial and we're dividing it by this x minus c, so like above when we divided by x minus 2, we know that the remainder is going to be the same thing as what we get when we plug in that value. So just like what we got when we plugged in 2. Go ahead and, with that knowledge, take some time, fill out the rest of the front side of this worksheet. Go ahead and pause the video. I'm going to scroll down slowly so you can see the answers. Pause as necessary. All right, so number 6 really helps us with another new theorem in pre-calculus, is what we call the factor theorem. So when we evaluate a function and we use that remainder theorem and we plug in a number, that's c, and it equals 0, then we know x minus c is going to be a factor of f of x. And vice versa, if we have x minus c and we know it's a factor, then when we plug in that c value, we know the remainder is going to be 0. It's going to equal 0. And just a couple reminders graphically, we know that if we're talking about on a graph, when we have this remainder, then c is going to be an x-intercept, right? X-intercepts are the same thing as solutions, as zeros. There's lots of names for it. And we know that on a polynomial of degree n, we can have at most n real intercepts, right? So if we have a degree of 7, there can be 7 x-intercepts. There can't be any more, but there could be less. So we can figure out how to factor using this remainder theorem. It can be pretty helpful instead of having to do synthetic division and log division, but actually at the end you're going to have to do that as well. So in number 7 it says, let's show that 1 is a 0 of p of x. So to do that, we're going to take p of 1 and use that remainder theorem, and if it was a factor, then we know p of 1 is going to equal 0, and if you plug that in, we do get 1 minus 7 plus 6. So we do get 0. So we just proved that it was a 0. And now it says to use this to factor out p of x. So again, we have to still use synthetic division or log division if you would like. We're going to use 1 as our 0, and we're going to again write the coefficients of p of x. We're missing an x squared term, so I have to have a 0 as a placeholder. Bring down the 1. 1 times 1 is 1, plus 1 is 0. 1, we get negative 6, negative 6. Look at that, our remainder is 0. So we just divided our polynomials. Remember, we did p of x divided by x minus 1. And our end result is this polynomial here. And remember, we start with our constant term and work our way up. So when we divided them, we just figured out p of x can be broken down into this x minus 1. It is a factor. And we also now have x squared plus x minus 6. So we started factoring, and now we can continue to factor x squared plus x minus 6, finding two numbers that multiply to negative 6, and that add up to positive 1. So we know that's going to be 3, and we know that's going to be negative 2. So we just completely factored that polynomial. Number 8 and 9 on this page are review with writing equations and working with zeros. So go ahead again, take some time, answer those questions, check back, and see if you got the correct answer.